Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong, AWS, and Kong. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we hope that you do, we want you to send those in to us using the Q&A tab on the right side of your screen. Over on the right side of your screen, you'll also find the chat tab, and we'd like you to use that for more general comments or maybe just letting us know from where you're tuning in or what position you hold in your organization. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So our topic of discussion today is automate your API lifecycle management with Kong and AWS. I'm joined today by Claudio Acquaviva, software architect at Kong, and Anuj Sharma, container specialist solution architect at AWS. So Claudio, Anuj, thank you both for joining me today. Anuj, do you want to get our conversation started?
Awesome. Thank you so much, Cody, for the introduction. It's great to see or talk with you all today, virtually though. Hope you all are doing good. And again, thanks for coming to the webinar today. Quick introduction about me and Claudio. I am Anuj, based out of Seattle. Been with AWS for roughly around 6.5 years, but mostly focused in software development space for roughly around 17 or 18 years now. Claudio, you want to quickly introduce yourself?
Yeah, sure, absolutely. Yeah, Claudio Acquaviva speaking here. It's a pleasure talking to you all. Thanks so much for the opportunity to talk a little bit more about the AWS and Kong technologies. And so I'm a soft architect here at Kong for a little longer than 4 years now, as well as AWS ambassador. And then personally speaking, I've been working with AWS directly with AWS with multiple collaborations for over 2 years now. And it's been a fun ride. So again, thanks so much for joining us today. And let's get it started.
Awesome. All right. Thank you, Claudio. And thanks for being the AWS ambassador, by the way. It's great to work with you on a day-to-day basis. Always.
Yes.
All right. So let's get started with today's agenda, which is around automating your API lifecycle management with Kong and AWS. So let's see what we are going to talk about in today's agenda, which is like totally jam-packed for 60 minutes or so. We will first dissect the use cases which is resulting in the growth of APIs and see how the architectural patterns of API gateway and service mesh are evolving and coming to the rescue to this growth acceleration. We will go through the entire API lifecycle of the lifecycle of the entire API development, starting with Kong Insomnia for authoring all the APIs and all the way through API gateway and service mesh via the pipelines. In the end, we will see how easy it is to procure Kong Konnect via AWS Marketplace, and wrap up with an awesome demo by Claudio towards the end. If you have any questions along the way, please type them, and towards the end, Claudio and I will get to those. Now, APIs and microservices are growing roughly around 100% year-on-year basis. Each of these microservices have common elements such as access control, auditing, reporting, telemetry, traffic control, service-to-service communication, and pretty much even more. If you start coding the logic or these logic in each and every microservice and importing these logic in each and every microservice, it is likely that you are going to end up creating another monolith solution again and again, and we're going back to square one. This is where Kong and AWS come to rescue with products like Kong Gateway and Service Mesh. We will dive deep into both of these in just a bit. Now, what we're seeing as a part of digital transformation, customers are building microservices layer and exposing them as APIs to build or improve omni-channel experiences. Customers are also getting rid of their legacy systems and using various ways to move functionalities to cloud. One of them is Strangler pattern, where you move one functionality at a time to the newer system and slowly strangulate the legacy system using the abstraction layer. And the abstraction layer is also exposed as APIs. In last few years, we are seeing tremendous growth of SaaS-based application software vendors, and they usually provide their offerings via APIs. But last but not the least is regulations. In some countries, regulations require financial institutions to use open APIs. For example, open banking regulations in UK and Australia requires bank to use open APIs for third parties. Now, as the number of APIs are increasing, application connectivity becomes critical for a stellar digital experience. We are in the early days of APIs and microservices. Every new API we add or monolith we decouple into microservices essentially adds another layer of this connection. When we start defining a microservice, we start designing bounded context, which typically serves a single purpose business logic end to end. But for the purpose of running the whole business unit or for the whole business function, each microservice may need to communicate with each other over endpoints to fetch the data from one another. This is where service meshes comes into play. Now, needing a reliable network for APIs isn't new. This is why API management has been around for decades. But what has changed are the technologies. We moved from legacy monolith centralized stack to a decentralized modern stack, and API management solutions don't have just evolved yet. What's needed is a solution that can ensure reliable connections for both the cloud native and legacy workloads. What's needed is a solution that can help accelerate the transition for companies embracing modern APIs, modern API-led architectures. The cloud found rapid pace of adoption because it provided significant agility advantages over on-premise data centers. Initially, developers used to use the cloud for dev or test only, but over the time, the cloud matured towards running enterprise-scale production systems, including cloud-native apps. Containers are a key technology these days for microservices and cloud-native application that gets managed through Kubernetes. Along with containers came a shift towards agile approaches, DevOps, and CI/CD enabled to promote functionality faster into production with better quality and lower cost. The lifetime of a container is very short compared to the traditional virtual machine. Thus, the infrastructure became very dynamic with the use of containers. Two consequences of decentralization are the services get smaller and smaller, so that the number of APIs are exploding, and the number of agile teams are rapidly increasing as well. The other consequence is that at the same time, services are becoming harder and harder to control. There is less and less visibility. In this complex world, APIs and their connections enable decentralization. They are becoming the backbone for not only for application but for the business to open up new opportunities. All right, with all the investments in API and microservices, there's a huge amount of stress that is placed on the network. If the network connection or the connectivity between our API stops or fails, everything comes to a stop. Bloated services that include network and security functionalities have performance or scalability limitations, leading to service disruptions and outages. We need to ensure that the network is reliable, secure, and performs well. More than that, we need to make sure that all of our APIs are optimized to have the best connectivity possible. This represents both an opportunity and a risk. The digital world is really good for modernizing. Now, let's see why Kong and AWS can actually help together with your journey along the whole the modernization process. There are two parts to this partnership. One is how AWS is the best place to run Kong, and second is how Kong and AWS are jointly working together to make it useful for customers. Let me start with the first one. With AWS, you get around 80 availability zones spread it over 25 regions that you can build highly available, scalable, and reliable APIs using Kong data planes. You can optimize cost and performance by using AWS Graviton instances. These are our ARM-based instances designed by Amazon and provides up to 40% price performance benefits over comparable generation of x86 based instances. With the support of ECS, EKS, and ROSA, you get the support for rich container technologies. There have been around 20 plus native integrations between Kong and AWS. For example, Cognito and OpenSearch integration plugins are available out of the box, and Claudia is going to show you a demo also how you can use them. Using Kong plugins, you focus on writing your business facade, and it gives you the operational freedom by performing your APIs with AWS Lambda or AWS Fargate. There is a flexibility in the different kind of deployment options that you can get. You can use the infrastructure as code tool of your choice. Let it be CDK, Terraform, or AWS CLI to deploy the Kong gateway on AWS. Running Kong Gateway workloads on AWS lets you inherit around 54 different security or global security and compliance framework from AWS. Towards the end, we will also see how easy it is to procure Kong Gateway from AWS Marketplace, which also helps you to streamline your EDP spends to procure Kong. And finally, the other part of support from the other part is the support from both Kong and AWS teams. We have dedicated builders from both Kong and AWS who are deeply invested in the partnership, who will let you architect, deploy, and run your APIs frustration free. Kong is a differentiated software partner in AWS Partner Network, qualified with multiple competencies such as DevOps competency and AWS ISV workload migration program. With that, I'd like to hand it over to Claudio to take us and dive deep on the technologies like Kong Gateway and Kong Service Mesh, which I introduced in the session today. Over to you, Claudia.
Thank you, Anuj. Yeah, let me share my screen now. I hope you can see it. Okay, good. So yeah. First of all, to address the problem statement Anuj just described, Kong provides this end-to-end service connectivity platform. So the platform comprehends the two main layers, as you can see in this diagram. On top of it, we can see the management plane. Maybe someone may call it the control plane. So the control plane or management plane is responsible for the admin tasks. It's a very stable environment behind firewalls. It's supposed to be used only by the admins. And then you, as an admin, you go to the control plane, management plane, to define your APIs, to define policies to control the API exposure, and so on. Other than this, as you can see, there are a couple of other components available for you as an admin to provide observability capabilities, to check how this given API is being consumed, and so on and so on. And then the second layer of the platform comprehends two main products, the runtimes, as a matter of fact, two kinds of runtimes. On your left, you see the gateway responsible for the typical north-south traffic, typically implemented by in your edge computing layer. And then on your right, you see the Kong mesh, which is responsible for controlling the traffic you're going to have within your application. In other words, the self-mesh implementation. So again, Kong Gateway and self-mesh, that will be the ultimate integration of both products. So the first one responsible for the north-south traffic, the right one, the Kong mesh, will be responsible for the east-west traffic, or the traffic we got within a given application. As Anu said before, one of the main capabilities we provide is what we call the architecture freedom, meaning that the data planes or the runtimes can be deployed across all AWS platforms, AWS provides this time, including regular EC2s, if you will. A little bit more interesting, that will be Kubernetes, EKS, even EKS Anywhere, ECS, and so on and so on. So for instance, just to give you an example, I'm going to show you my demo in a moment. Two runtimes running at the same time. The first one running my local Docker environment, running my laptop, my local laptop. The second one running EKS cluster, of course, in AWS cloud. So yeah, that's it. This slide over here is just listing the main capabilities Kong Konnect, which is the name of our platform, provides. So first of all, it's quite flexible. Again, as I said before, one of the beauty of the platform is to allow you to decide to support, as a matter of fact, any technology decision you might have along the way in terms of topology. So let's say you want to deploy a brand new runtime running in your on-premise environment, and then you're going to move the workload to the cloud. This kind of support is very, very important for you to have from our side. So kind of, very flexible in terms of topology, in terms of workload, supporting your workloads and so on. The second one, very efficient and automated. I'm going to show you an API lifecycle being managed by AWS DevOps tooling, including code commit, code pipeline, code build. It's kind of, the point is Kong supports any DevOps tooling you might have. I'm going to use DevOps tooling, but then again, you can use your, if you will, your Terraform or Jenkins infrastructure, if you will, and so on. So the third one will be like an extensive and fast, like, not just supporting these multiple runtimes at the same time, but actually all these runtimes can be extended with the brand new capabilities you can develop yourself, or you can buy from third-party partners and so on. So I'm going to talk a little bit more about this extensibility capability in the next slide. Last but not least, secure. The control plane is offered as a SaaS solution. So kind of, the SaaS solution, is a multi-tenancy and fine-grained access control in order to provide a more, even more secure control plane environment for you. I forgot to mention this. The control plane is offered in two flavors: as a SaaS offer, as I said before, and then as a self-managed, meaning that you are going to deploy your own control plane in any platforms you might have, and so on. The runtimes, on the other hand, is totally managed by you. You're going to decide where your control plane, your runtimes are going to be running along the way. Extensibility, one very, very, very important capability we provide. So it's not just about to define APIs and control the exposure, but actually to implement typical policies we have in the API gateway layer. For instance, authentication. For instance, Anush just mentioned Cognito as one AWS services we integrate. Very, very important in terms of security. So this time the API gateway, more precisely the runtime, will be integrated with Cognito to implement the OpenAPI-based authentication process. Not just Cognito, but any other identity provider you might have in your environment. So security is one thing, Log processing, very, very important as well, to externalize all the data related to the API processing to external infrastructure, including AWS OpenSearch, including AWS managed Prometheus and managed Grafana services, and so on. Of course, not just supporting AWS services, but then again, other log processing and real-time monitoring you might have in your environment. So again, security based on OpenAPI-Connect, based on API keys, based on any security mechanisms you have today, but also log processing, rate limiting, throttling policies, and so on. So this slide over here is just outlining the main topics when we come to the extensibility discussion. Other than this, we provide what we call this plugin development kit. So you can develop your own plugin and inject into the runtime instances in order to implement a brand new functionality. So kind of a very, very important capability we provide this time. But then again, when we come to the enterprise class kind of application, solving these edge computing or north-south traffic, it's absolutely important, but not exactly enough. So as a matter of fact, again, if we consider enterprise class application, there are other kinds of traffic we should also support and address. So as a matter of fact, this slide over here, on your left, you see the classic kind of traffic, again, being implemented by the edge computing, but then there are two other kinds of traffic as well. So the second one will be the cross-application connectivity, the kind of traffic you got inter-applications. So one application is going to talk with another application. That will be the case to control this kind of traffic as well. And then the third kind of traffic will be the in-application connectivity. Some people call it the intra-application connectivity, meaning that you want to control the traffic you got within a given application. In other words, that's where the self-mesh architecture pattern works is. So as a matter of fact, this slide over here is trying to show how the two products we provide, they can work together in order to support all these three kinds of traffic. Number one, on the top, again, the classic edge computing layer being implemented by the Kong API gateway. And then the second kind of traffic, the inter-application traffic, again, will be managed, will be controlled by another API gateway responsible for these specific internal and inter-application traffic. And then, as you can see in my diagram here, I got two applications, the banking product application, the training product application. They're going to talk to each other. Again, the Kong gateway will be responsible for controlling this communication. Within each one of these applications, you're going to have multiple components. And then, again, that's where the self-mesh is going to be. So the self-mesh, again, is going to take care of the third kind of traffic. So all these pink circles, they're representing the sidecars controlling the incoming, outgoing traffic we got from one microservice to the other. Just a slide over here, just outlining or listing the main capabilities Kong Mesh, which is the product we provide implementing self-mesh architecture pattern. So again, Kong Mesh is what we call the universal self-mesh implementation, meaning that logically speaking, a single self-mesh implementation may have multiple microservices, of course, but some microservices running on VMs, other microservices running Kubernetes. It's totally fine to have these platform combination to in your self-mesh implementation. Again, that's why we call it the universal self-mesh. Some microservices running Kubernetes, other microservices Kubernetes number 2, other microservices running on VMs, and so on. So one of the main capabilities we provide, one of the main differentiators we provide as a self-mesh implementer. Other capabilities like native OPA integration, the well-known OPA engine. you typically use in Kubernetes clusters and other engines, of course. But then again, you can use it in your SFC-Mesh implementation to implement access control policies as well. So that's it. So what we call these multiple environments a zone. That's why we call this multi-zone deployment, meaning that, again, some microservices run in zone number 1 based on VMs, other zone number 2 based on Kubernetes 1, region 1, for instance, other microservices running Kubernetes number 2, region number 2, and so on. So that's kind of SFC-Mesh deployment we're talking here, hybrid SFC-Mesh deployment again. Another topic I want to talk a little bit more is the API ops. So what does that mean? API ops is we are just applying the GitOps methodology and principles to the API lifecycle as well. So this diagram here is describing what a API ops infrastructure would look like. So getting started with Insomnia down here. Insomnia is our API spec editor. We also provide, I'm going to show you in a moment during my demo environment. And then Insomnia supports a Git-based repository as an API spec repository. I'm going to use AWS Code Commit, playing this role for us. And then behind the Git-based repository, we're going to have your CI/CD pipeline. In my case, in my demo environment, I'm going to show you my CI/CD pipeline being implemented again using code pipeline, code build, and so on. The CI/CD pipeline will be responsible for translating the API spec, the OpenAPI or Swagger spec, into specific Kong objects, Kong APIs, Kong plugins, and so on, in order to get the actual API being deployed to the control plane, therefore to the data plane sitting behind the control plane. And as a matter of fact, another slide over here showing case what a typical API lifecycle would look like. So getting started with the design time, again, I'm using Insomnia to design and to evolve the existing API specs in order to create a new version of giving API spec. And then I'm going to use my DevOps infrastructure. Again, my case, AWS Code Commit, pipeline, build, and deploy to take care of the actual API deployment for us. As a matter of fact, your existing CI/CD pipeline is going to be enhanced by the technologies we provide. So as you can see, there's an INSO technology over here. It's an INSO CLI. INSO CLI is responsible for translating the API spec into a specific Kong declaration, which is going to create our Kong objects. Again, the Kong routes, Kong services, Kong APIs, plugins, and so on. The deck, there's another technology we provide, is going to be injected inside your existing CI/CD pipeline. Deck is responsible for taking a declaration generated by INSO CLI and submitted to the Kong control plane. And then the control plane, again, is going to publish the APIs to the data plane sitting behind it. Not just the APIs, we're going to get not just the APIs getting deployed to the API gateway, but also to the Kong developer portal, which is the component we provide to document the APIs you have, not just to provide API documentation, but actually to provide self-services so the developers can try the APIs out. They can issue their own credentials, for instance, API keys, user ID passwords, in order to consume these APIs. In terms of AWS deployment, so kind of, again, this is just a theoretical view perspective of the API lifecycle. So in terms of implementation, again, this is an example of implementation of API ops using both technologies, Kongs and AWS's. Again, we're going to get started with API designers. They're going to take their existing specs or even creating brand new ones using Insomnia. Again, I'm going to show you Insomnia in a moment. Insomnia, the API spec editor. And then Insomnia is going to rely on Git-based AWS code commit as our Git-based repository. And then every time we push a new version or new API to code commit, the CI/CD pipeline is going to be triggered. And then, of course, it's going to take care of the API deployment itself. So the code pipeline and code build will be responsible for publishing not just the regular microservice lifecycle as well, but this time they're going to be responsible for deploying the APIs themselves. So again, they're going to publish the APIs to the control plane, and then the control plane is going to publish the new version API across the multiple data planes, the multiple runtimes we have in our environment. So that's a typical lifecycle, API lifecycle you have in your production-ready environment. Of course, I'm going to show you a very simplified CI/CD pipeline. So, and then again, of course, your own pipeline is going to have so many nuances, so many other steps to implement and so on. There's another comment here. As you can see, the data plane is kind of a they're part of very dynamic environment, I should say. So very, very common to spin up new data planes along the way, because behind the scenes, you are transferring your workloads from one environment to the other. So there's another life cycle here. That's the point. So besides the API ops life cycle, taking care of the API deployment itself, we have to have another life cycle taking care of the data plane deployments. So for instance, you're going to, again, as I said before, you're going to transfer your workloads from your on-premise environment to the cloud. So that will be reasonable to spin up new data planes to protect this brand new environment you're going to build along the way. So that's why we have to have other infrastructure to take care of the data plane life cycle as well, the runtime data plane life cycle as well. That's why I have included other AWS services. Again, AWS CloudFormation. Some we could include CDK as well. That will be another way to deal with the data plane deployment, and then ACM to support digital certificate and private key life cycles, digital certificate rotation, this kind of thing. AWS Secrets Manager, for obvious reason, to store any secret the data plane might need along the way, including passwords, including licenses, and so on. So again, the point is the API ops should be support the two kinds of life cycle, the API ops life cycle and data plane life cycle as well. So as you can see here, I got two data planes, one running ECS, another running EKS. Both are consuming exactly the same collection of AWS services. Again, Cognito, OpenSearch, AMP, AMG, and Elasticache for Redis to implement caching, rate limiting policies, and so on. Now that's demo time. I'm going to show you a simplified topology. So again, I'm going to show you the Insomnia taking care of the API spec, as I said before, code commit as my Git-based repository, code pipeline and code build taking care of the pipeline, therefore the API deployment. And then I'm going to show you the control plane, the SaaS version of control plane, which is the Konnect control plane, again provided as a SaaS. And then my data plane, as I said before, I got two data planes, not just one. Two data planes. The first one deployed in a Kubernetes cluster running AWS Cloud, of course, and then the second one running my local Docker environment. And that's it. So I'm going to stop sharing my screen now. Before we get started, stop sharing my, got to, am I still sharing it? Yeah.
Yes.
Yeah, I'm sorry. So again, before we get started, I just wanted to go through quickly our Konnect control plane. Again, I'm logging to it. So again, we got this Notion runtime manager. So runtime manager responsible for the runtime instances, data plane instances for the API gateway. As I said before, I got two runtime groups. The first one based on EKS. I'm going to show my EKS cluster in a moment. The second one based on my local Docker environment. So every time I publish one API to runtime group number one, is going to be published to Kubernetes. Or if I publish to the Docker runtime, Docker-based runtime, is going to be visible for only consumers of my Docker environment. So again, runtime manager is responsible not just to supporting all these multiple data planes you're going to have along the way, but actually is responsible for deploying collections of APIs for specific runtime groups. So again, the default runtime group will be responsible for exposing API collection number one. The second runtime group will be responsible for exposing a different collection APIs. Very, very useful, very powerful capability, powerful and useful capability when we come to environments like API promotion across multiple environments, development environment, pre-production, production environment. So each one of these environments will be a runtime group related to each one of them. So when we want to promote one API from one runtime group to the other, that's just a matter to play with these APIs, where the API is going to be is being exposed this time and then promoted to another one. For instance, in these default, I don't have any route available for me. So there's nothing here. On the other hand, for the Docker-based runtime, I got some APIs already defined. So as a matter of fact, if I go to Insomnia API spec, Insomnia, I can send requests to my data planes, not just to, I'm going to use Insomnia not just to edit my API spec, but also to send requests to my data planes. So if I send a request to this guy over here, that's the runtime related to the EKS cluster, which is the runtime group that doesn't have any API deployed this time. So different behavior. If I go to my local host and try to consume this API over here, I am able to do it. Because again, there's another runtime related to another runtime group, this time with a already API deployed. So again, my local runtime group has got an API already deployed. My EKS-based runtime group doesn't have any. That's the runtime group we're going to work right now. We're going to deploy a brand new API. This time is going to be deployed to the Kubernetes-based runtime group. So, and then in terms of API, here's the API we're going to deploy. Let me zoom in a bit more. So I'm calling it the simplest HTTP bin API spec. So first of all, this is a standard OpenAPI spec, as you can see here, kind of defining the server going to sit, is going to be protected by the API. The path, I'm calling it the simplest because the only path I'm defining this time, there's this /deck. We're supposed to have all the methods, post, put, patch, and so on. But then again, to keep the API spec as simple as possible, I'm defining just this /get. And then, of course, I can try it out, and so on. So here's the result code 200, and so on. Insomnia provides a linting capability. So every time we got a spec error over here, I'm going to get this warning saying that, hey, your API spec is not right. So you are supposed to correct it. And then, as I said before, Insomnia provides the capability to integrate with any Git-based repository. This time I'm using my own, but then again, you can use yours. Again, as long as you got a Git-based repository, you can get Insomnia connected to it. Again, I'm using my code commit. As you can see over here, the Git code commit US endpoint, and so on. So if I push or a new API version to the Git-based repository to code commit, I'm going to get my CI/CD pipeline working in the background. Before we doing it, there's one last comment here. I hope you can see this x-kong setting over here. That's the way we do to inject in your existing API specs our policies. As a matter of fact, I'm using this x-kong-plugin setting in order to inject a rate limiting policy to my API, meaning that in my case, I'm saying that this API is supposed to be consumed only 3 times. I'm going to change it to 5 times a minute, and so on. So again, I'm injecting the specific rate limiting policy into my API spec, saying that this API is supposed to be consumed only 5 times a minute. I'm doing the rate limiting, but I can use exactly the same mechanism to inject other policies, including authentication, integrated cognito, and log processing, and so on and so on. As a matter of fact, all the plugins we provide, you can use all the plugins we provide in this using this mechanism over here. So what happens if we commit this API spec to my code commit and push it to my code commit? So here's my code commit right now. My repos. So I'm pushing my Kong repo code commit. So that's where my Insomnia, Insomnia is going to store all the API specs. But then again, since I push it to code commit, I'm going to get my pipeline at work. As you can see, here's my pipeline, and it's already in progress, as you can see over here. So it's going to take 2 minutes or so to complete. While we wait, I just wanted to take this time to show you, again, the extensive list of plugins we provide. Again, these I got the proxy caching plugin already enabled, but then again, we can start enabling other plugins. So all these authentication-based plugins we provide, base authentication based on user ID, password pair, API keys, LDAP-based authentication. Mutual TLS, very, very, very important plugin to implement a mutual TLS with your consumers. OpenAPI Connect, that's the one we use to integrate the Cognito. Security-based plugins to implement, for instance, OPA-based access control policies to implement cores, IP restrictions, so kind of defining whitelists and blacklists. So if you got a requests coming from this blacklist list, of course, the consumer is going to get in there. In the traffic control, there's a very, very interesting one. So multiple traffic control-based plugins. So to implement Canary at the API gateway layer, GraphQL integration. So you got a GraphQL server sitting behind the gateway. You can connect to it. Mocking, you can mock your upstream services, if you will, not exactly provision our actual upstream service, but instead, playing with the mocking plugin in order to do it. Proxy cache advanced in order to implement proxy cache, or with the Elastic Cache Redis integration in order to do it. Rate limiting again to implement fixed window, slide window algorithms for your rate limiting policies. Request sizing to limit your the size of requests in order to protect your upstream services. Route by header, define routing policy based on a specific header you might have in your requests, and so on. WebSocket validator, very, very important, like, to validate your WebSocket requests or connections you got, and so on. Serverless, this is very, very important to abstract the AWS Lambda functions you have in your existing environment. So the consumers, they don't know you got a function sitting behind the gateway. They're going to send regular REST-based requests to the gateway. The gateway is going to route your request to AWS Lambda sitting behind it. Finally, analytics and monitoring. Again, we provide specific plugins to integrate Datadog for Prometheus. These Prometheus, of course, as you can imagine, can be integrated AMP as well. Amazon Managed Prometheus service, and so on. There's a brand new plugin, Open Telemetric, based on OTLP standard, which is very, very important. So kind of all the industries is going to this OTLP standard when we come to monitoring, tracing, and so on. Zipkin specific plugin transformation in order to transform for instance, this one is interesting. You're going to transform a REST-based request into a Kafka event, and then the gateway is going to publish a new Kafka event. Your existing Kafka streaming infrastructure could be AWS services as well, and so on. Request transformer, request response. So kind of you want to transform your request before routing to the upstream. Request the response before getting back to the consumer. Finally, last but not least, the logging-based plugins. So again, supporting all kinds of mechanisms we got this time. So file-based log or statsd-based, for instance, this one we usually use to integrate the AWS CloudWatch. As you know, AWS CloudWatch provides a specific agent based on statsd. So that's the regular plugin we use to integrate the CloudWatch. syslog based TCP log. This one is interesting. This time we're going to externalize all the requests that have been processed by the gateway to external infrastructure, maybe AWS OpenSearch, using a data stream connection with the AWS OpenSearch, and so on. So I think our pipeline is done. Yeah, it is. And then if you go back to our control plane, first of all, not sure if you call this, but again, if you go back to the Kubernetes runtime group, Kubernetes based runtime group, again, I can see my runtime instances over here. And as I showed you before, there wasn't anything deployed, but this time we got our simplest based Kong service deployed. Not just the service, but the route as well. More than that, here's the rate limiting plugin we asked to get published as well, to get deployed as well. So the three main objects: the Kong service, abstracting the upstream service for us, the Kong route, exposing the service to the outside world, and the rate limiting plugin controlling the exposure. So what happens if you go to Insomnia and try to consume the route again? So we are supposed to get a actual result. This time, the plugin, the API is being deployed. The control plane has already published the API to the data plane running Kubernetes, and then I'm able to consume the data plane, and then I'm able to get some result. More than that, as you can see over here, we got these rate limiting specific headers controlling the exposure. So if I keep on sending requests to the data plane, eventually I'm going to get 429 error code, meaning that I have reached the rate limiting policy we have previously defined. We have defined in our API spec. So that's it. So kind of, again, this is just an example of very, very simple CI/CD pipeline being built, crafted using the AWS DevOps tooling. As you can imagine, for a production-ready environment, you're going to have so many nuances, steps, implementing your, existing CI/CD pipeline and so on. So I think that's it. Not sure if we got questions from the audience.
Yeah, I think let's move to the CTS slide. So first and foremost, a very important call to action. We have Kong Konnect, the UI that Claudia was showing. It is available for a free trial via AWS Marketplace. Try it through November 15. You can scan this QR code, and even the link is also pinned on the top of the chat window also. that will give you an option to procure Kong Konnect and make it run under free trial. And what it means is you can try out pretty much everything that Claudio
Yeah.
demonstrated and explore the plugins um, uh, which are offered in a paid subscription for Connect for free, and try it out in your specific environment, and see it by yourself. I think
Yeah.
this is where the demonstration will come handy. Try it by yourself, and specifically the functionality is exposed in terms of plugins. So try out these plugins by yourself and see the wonders of Kong API Gateway. Right. Uh, Again, the free trial for Kong Connect is available via AWS Marketplace. Also, run it through and try it through November 15th, and see Kong in action, Kong
Yeah.
Connect in action. So going to the questions we had, I don't see anything in the Q&A box, but feel free to ask questions there. I'm going through the chat list. I do see one question which says, where are the API keys stored?
Yeah.
So,
I think I can handle this one. Yeah, the API
yeah,
keys, they are defined. They are defined in the control plane, but then when the control plane publishes the APIs and policies to the data plane, the API key is going to be published as well. So it's going to be stored in the data plane's memory. So no local persistence. So kind of, if you destroy the data plane and create it again, the control plane is going to publish again the APIs and policies, including the API keys also. So that's it.
awesome. We have another question which says, how to best deploy Kong on AWS? Great question.
It's a great question. Yeah.
So this year we partnered with Kong to create few CDK constructs. The CDK constructs are available in at CDK dot, and I'm going to paste the link also here in the chat. This is a sample application that we have created to get you quickly started with Kong Gateway on AWS using the CDK constructs that we have created. There are around three different CDK constructs, one for control plane, another one for data plane, another one has the core framework related things that you don't need to worry about. If again the question of how to best deploy Kong on AWS typically has two different elements. One element is also what you are actually currently using. If you're using in your existing environment, best to use continue using that too. Uh, the constructs that we have created for CDK is can typically work for if you are familiar with type scripting as an example, if you're familiar with CloudFormation as an example. If they're using CloudFormation in your environment, the constructs will generate it for you.
Yeah. I should say CDK, one of the best options we provide this time to take care of the con deployment, especially again, especially when we come to this data plane life cycle again. You're going to destroy data plane, create new data planes along the way. I think again, CDK is a great option we provide this time.
All right. Uh, any other questions? All right. So I do see a question that says, can you talk about how the Kong API gateway supports API version control.
Yeah, Konnect provides a specific versioning capability. You can store multiple versions of giving API, and I would say as a combination of Konnect capabilities, storing the versioning, the versions of giving APIs, and your CI/CD pipeline. Maybe your CI/CD pipeline is going to create versions, new versions along the way, or retire existing versions and so on. So again, the Konnect control plane will be responsible for storing the versions of your giving API. The CI/CD pipeline is going to take care of the the life cycle again, like promoting one version to the as the production version and so on and so on. Hope it, not sure if I have answered your question, but yeah, that will be it. Why Kong on AWS and not with a Z? Not sure if I understand this one. You mean availability zone? Yeah, of course. When we come to these kind of deployment, as a matter of fact, Kong is going to be deployed in the AWS runtime you have chosen. So, Azure. I'm sorry. Yeah. From our standpoint, from the Kong standpoint, yeah, Azure. As long as you got, the runtimes you support, again, Kubernetes, again, VMs, and so on. Yeah, absolutely. You can deploy Kong in Azure as well, and that will be the ultimate multi-cloud deployment. So some runtime instances and in multiple clouds and so on. So that's it.
All right, Anuj and Claudio, while we wait for any last minute questions, I'm going to go ahead and give away our gift cards. So our four winners are Wyshawn W, Andrew T, Marius C, or maybe Marius C, and Nelson N. So to our four winners, congratulations. Keep an eye on your inbox to claim that gift card, but if you don't happen to see that email, do check your spam folder. All right, Anuj and Claudio, not seeing any more questions. I would like to give each of you an opportunity to leave our audience with any parting words before we close out and take this off the air.
Again, firstly, thanks a lot for joining us today. Hope you saw the value proposition of Kong and AWS partnership to build a connectivity platform using API gateway or using Kong API gateway solutions and Kong service mesh related solutions. This can really help you accelerate your journey of migration to modernize end to end. Again, as we have mentioned in the call to action slide, feel free to try out Kong Konnect in free trial from AWS Marketplace to get a hands-on feeling on all the plugins where the functionality is offered from a gateway perspective. And good to talk with you today. Thank you.
Yeah. Again, it's been our pleasure to talk to you all. Please don't hesitate if you want to ping us later on to continue with these fascinating discussions about AWS, Kong, multiple regions or multiple environments playing together. Will be our pleasure. Thanks so very much.
Well, Claudio and Anuj, thank you both so much for joining us today. I would like to thank AWS and Kong for sponsoring today's program. And to our audience, thank you so much for spending the last hour with us. We really value your time, and we also really value your feedback. And so as soon as we close out, a survey will pop up on your screen, and we'd really appreciate you filling that out for us and letting us know your thoughts about today's program. I'll also remind everyone that this program was recorded, and you should be receiving a copy of that recording shortly. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day. And Anuj, Claudio, thank you so much.
Thank you.
Pleasure. Thank you. Bye.
Bye-bye.